There is a much shorter way to write the electron configuration. Now imagine if you're having to write out the entire code of where all the electrons live every single time, that's going to take you forever. And if you don't know what electron configuration is, look in the description down there. It'll take you to a previous video that tells you what we're talking about. But if you understand electron configuration, you really want to know, is there a way to shorten this, to compress this? And there is. It's called noble gas electron configuration. Let me show you how to do it. Noble gases then are elements in group 18, and they have a full outer shell of electrons. That means they have 8 electrons in their outermost shell. This means they are chemically stable and unreactive with other elements. What it really means is that they don't need to combine with other elements or give electrons away or steal electrons or change their electron. Their electron configuration never changes. They get the name noble gases because back in the olden days when you thought about nobles, they didn't hang out with the commoners. The commoners being every other element on the periodic table. Well, where are they then? This group right here, they are the noble gases. They have 8 valence electrons, or in the case of helium, it's kind of special up here because it has 2 valence electrons, but we've seen as we write out electron configuration, 2 electrons, if that's your outermost shell, is full. So helium's perfectly happy. It's lumped in with the noble gases. And all the other ones down here, they have 8 valence electrons. Now here's the point. Here's what we need to use this for. If we're going to shorten up electron configuration, we can use the electron configuration of the noble gases as sort of a cheat code to shorten down our very long electron configurations that we've been writing. So here we go. I've said before, if there's a box on the screen, boy, in my class, I'm telling students, write this down, put a box around it in your notes because we're going to be using this throughout all of chemistry. So I would take the time to write this down as well. Now, I already mentioned the whole point of this is to shorten the electron configuration. So how do we do that? We write out the entire electron configuration, and then we find the noble gas lower in atomic number and closest to the desired element. That's not going to make sense until I do an example, and I'll do an example as soon as I click to the next screen. Then we're going to write the noble gas in brackets. I'll show you what that means. And then we'll write the remaining electron configuration. Again, this is to shorten it up. Now, this is what the whole thing's going to look at. If we have aluminum and we shorten it up, notice we end up with these weird brackets. Neon is one of our noble gases, and then the rest of the code afterwards. Now, hold on. This is my disclaimer. This does not seem like a shortcut. If the goal here is to shorten up the electron configuration, why would I need to write out the entire electron configuration to be able to shorten it to this other thing that you're telling me is noble gas electron configuration? Well, the thing is, rarely are you going to do it that way. Usually what you'll be shown, and most periodic tables show the electron configuration. Most questions in chemistry show the electron configuration because it's already shortened. But you need to know what that shortened code means. You need to be able to expand that into the electron configuration. So that's why we started with regular electron configuration, and now we're going to take it and turn it into this simplified version. And then now if you understand the simplified version, you can just use that and you work your way back out to the big electron configuration if you ever need to. So let's try it. Let's see if we can write out the noble gas electron configuration for titanium using the steps that you just wrote down on the last screen. The first thing here is we need to find it on the periodic table to be able to write the electron configuration. Here's titanium right there. Titanium is number 22, which means it has 22 protons. And if it's electrically neutral, then it's also going to have 22 electrons. E negative is shorthand for electrons. We come over here to what I call the electron ladder. And we're going to write this out until we write out the entire electron configuration. Again, we're learning how to shorten this up. And then the goal will be, now I have a shortened one, I can expand it out. So let's write it out. The first 2 electrons will live here. I've used up 2. 2 more electrons can live here. Now I've used a total of 4. Right here, I've got 6 can live in that, and 2 can live here. I'm going to write that in, 6 and 2. That's 6 plus 2 is 8, plus the 4 I've already used. Now I've used up 12 electrons. I have 22 to be able to use. So I'm at 12. The next ones are going to go here and here. That holds 6. This holds 2. That was 8 more that I just put on there. That gives me a total of 20 that I've used up. Oh, I'm trying to get to 22. So the next ones, they're going to go right here. 2 more in this one. Now I've used up all 22 electrons. So let's write out the electron configuration in the order that we filled them up. It's called filling order. We've got 1s2, 2s2, 2p6. Now, if you're following along, I'm right here, working my way this direction. 3s2, then right here, 3p6, 4s2, 3p6, 4s2, and then 3d2. The next, we find the noble gas lower in atomic number and closest to the desired element. The desired element that we're working on is titanium. So I'm at 22. I'm going to go to 21, 20, 19. I got to go way over here for 18. Oh, look here, 18 is argon. Argon is a noble gas. Argon has 18 electrons total, and it has 8 in its outermost shell, so it's never ever going to change. Well, let's do this then. We have 2 electrons here, 2 more is 4, 6 more is 10, 2 more is 12, and 6 more is 18. So let me do this. This is 18 electrons in electron configuration. So this is the electron configuration for which element? For argon. So I have argon in brackets. And just to show you, this entire electron configuration now is represented by this symbol, the brackets with the argon. And then I write everything that I have left, which is 4s2, 3d2. Okay, look, we've done this. We put the noble gas in brackets. Now we write the remaining electron configuration. And this right here is the electron configuration. Is the noble gas electron configuration for titanium. See how it's shortened? This is nice, right? Now, if we get good at this, then we'll just immediately know which element that represents without having to write out the entire electron configuration. Let's try sodium here, writing out the noble gas electron configuration. Number 1, we write out the electron configuration. If you don't know what that means, again, you've jumped the gun. There are links in the description that'll take you back to another lesson that'll walk you through everything I'm talking about right now and show you what this crazy ladder thing I've got over here is. But we need to find sodium right here. Number 11 is sodium. That means it has 11 protons, but if it's electrically neutral, it also has 11 electrons. E negative is shorthand for electrons. So I need to put 11 electrons on my sodium. I come over here to my ladder and I start filling it in. This orbital holds 2. I've used up 2. I'm trying to get up to 11. This next one will hold 2 more. I've used a total of 4. I have 7 more to put on there. This can hold 6 electrons. And I only have 1 left, right? Because I just put 6 in the 2p orbital. And I'd already used up a total of 4. So that's 10. So when I get to here, this can only hold 1. Let's write these out in the order that we just filled them in. That's called the electron configuration. 1s2, 2s2, 2p6. I'm right here. Then we go to 3s1, 3s1. That is the electron configuration for sodium. But we're trying to write the noble gas. We're trying to learn how to write the noble gas configuration. So let's do this. Sodium is right here. It says, find the noble gas lower in atomic number and closest to the desired element. Our desired element right now is sodium. So if we are at 11, let's go backwards. We get to 10. Well, look here. 10 is neon, and neon is a noble gas. Neon has 10 electrons. So neon's electron configuration must represent 10 electrons. Okay, here's 2. Here's 2 more. That's a total of 4 electrons. And 6, that is a total of 10 electrons. So look, if we were to write out the electron configuration for neon, this is what we would write. So we can use this as a shortcut. I write the brackets down here, which is the next step, by the way. We just did that. We're doing this right now. And then I'm going to put Ne right here because this is the noble gas. This is the electron configuration for neon, which is a noble gas. So its electron configuration isn't going to change. So we'll put it right here. Then we write the remaining electron configuration, which is 3s1, that part right there. This then is the noble gas electron configuration for sodium right here. Let's look at this in another way, because as I mentioned before, oftentimes this is how we'll see electron configuration written, because it's shorter, takes up less space, takes up less time. And then sometimes we might need to be able to expand that into something to truly understand where all the electrons are living. We'll need to find helium. All right, let's go find helium. Helium is right here. Helium is number 2 on the periodic table, which means helium has 2 electrons if it's electrically neutral. How many more electrons does whatever this unknown we're looking at have? So this helium right here represents 2 electrons. This represents 2 electrons, and that's a total of 6 electrons. Well, what element, as long as it's not an ion, what element has 6 electrons? Well, right here, carbon is number 6 on the periodic table. It has 6 protons, and as long as it's not a positive ion or a negative ion, then it's going to have 6 electrons. Also, the element in question is carbon. And then also, just to show you, we can expand this out to its complete electron configuration, which we'll do right here. We write out the electron configuration for helium, which is pretty easy because it only has 2 electrons. 1s2, that's helium. Then 2s2, then 2p2. See, we can do it all. One more then. We have argon, 3d10, 4s2, and p5. I've written this a little different just to show you it can be written any number of ways. We have 3rd energy level, d orbital, there are 10 electrons. 4th energy level, the s is filled and the p are filled. I just didn't put a 4 here because oftentimes you'll see it written without that. Let's go find argon. Argon's got to be our noble gas, so we come and look in group 18. Oh, here we go. There's argon. It has 18 electrons. If we go ahead and fill this out, then that argon represents 18 electrons. There are 10 more here, 2 more here, and 5 more here. That's 10 plus 2 plus 5. That's another 17. So we have 18 from the argon plus the 17 that come after that. That's a total of 35 electrons. Now, assuming we don't have any ions, right? This is just a normal element. Well, what element would have 35 electrons? Let's go find it. Here we go. We've got, oh, look right here. Bromine has 35 electrons. So this element is bromine. And if we write out the complete electron configuration, the first thing we're going to need to do is write it out for 18 electrons to represent this argon. I'm going to go ahead and do that. It's all going to show up on the screen, and we'll talk about it in a moment. I've completed my ladder over here. I'm going to write them out in order. This is the argon that we have in the brackets. 1s2, 2s2, 2p6, 3s2, 3p6. Let me just put the brackets in here to show you that that is the electron configuration for argon. Then we just go ahead and include everything that was left, 3d10, 4s2, and 4, I'll put the 4 there, p5 to show you it can be written all these ways. Now here's the thing. In the next lesson, we're going to start looking at valence electrons. The electron configuration and the noble gas electron configuration help us understand how many valence electrons an atom has. Now, why would we care about that? Well, I tell my students, that's the launch pad to everything that we're going to cover for almost the rest of chemistry. The valence electrons become the most important part of understanding chemical reactions at the very beginning. And in order to know what they are, you have to understand this electron configuration and its shortened code, noble gas electron configuration. From this whole thing, I can tell you that bromine has 7 valence electrons. And in the next lesson, that's exactly what we're going to learn. We're going to learn how to take the electron configuration or the noble gas configuration and find out how many valence electrons an atom has. And then at a lesson much later, you can click to that one if you want to jump to it. We're going to expand on valence electrons and drawing Lewis structures, and you're going to become really, really good at this and really good at chemistry. So keep on learning.